Good morning everyone. Welcome to the chapter 2, and we will be working out on the MCQs related to gravitation and circular motion. Okay, though in your book it stands out to be thermal physics is your next chapter, but still I would like to start with this particular topic. Right, now let me continue with this. So the problems, so many of them have been saying that why only 5 problems? Why can't we have 10 problems as a homework? I'm very much impressed about the working of how you people are interested into this. And moreover, since the exams are approaching faster, I think we need to accelerate ourselves to put more number of numericals. And hence, I also thought that 10 problems would be fine. So 5 problems would hardly take 5 minutes, 10 problems will take 10 minutes. That's what I assume. So anyway, so today I'll just be discussing about the first homework only from circular motion and gravitation, okay, which comprises of 10 problems. So I'll just be discussing about what are these problems, what are the clues behind it, and tomorrow you'll be getting the solutions for this also. Okay. Now, let me pull my, right, okay. The first question, the object is at the end of a wooden rod, rotates in a vertical circle at a constant angular velocity. What is correct about the tension in the rod? So you have a wooden rod which rotates in a vertical circle with constant angular velocity. What happens with the tension in the rod? There are 4 options given. Now, as you already know, what happens to a tension? When a rod is rotating in a vertical circle, what will happen to tension? Will the tension remain the same? Will it be larger? Will it be greater? And if it is larger and greater, then at what positions will be larger and greater? This we have already explored using a formula. Think about it and then try to answer it. Okay. Now let us move on to the next question. A mass connected to one end of a rigid rod rotates at a constant speed in a vertical plane about the other end of the rod. So you have a rigid rod, you have a mass over here, and this is rigid rod has a mass? No. Okay. The force exerted on by the rod on the mass is. Again, the problem is very similar to what you have learned earlier. Okay, the previous problem. So think about it as once again moving in a vertical plane. Okay. When the question is about vertical plane, I'll just give a clue. The tension is not going to be a constant. The tension will be higher at some point, tension will be lower at some point, and the tension keeps on varying. Why does this happen? The reason is because if you apply your free body diagram, you will come to know that sometimes it is tension minus mg is equal to mv square by r. Since the particle is moving inside a circle, so therefore, if it is moving along a circle, that mv square by r comes into play, right? So based on this, tension will vary. So when it is at this edge, that is at the bottom, below most end of it, let me use a different color of the pen of the cursor, right? When it is at this edge, you get a different tension. When it is at this edge, you get a different tension. Here it is different tension, and so on. Okay, now let me move on to the next question. An object of constant mass is tied to the end of a rope of length L, and made to move in a horizontal circle. So made to move in a horizontal circle. Earlier it was vertical circle, now it's horizontal circle. The speed of the object, now it is something like this. So this is a string, this is the object connected, this is your finger, and you are making it to move in a horizontal circle like this. Then the length of the rope is then changed. Speed of the object is increased until the rope breaks at speed v. The speed of the object is increased. You are increasing the speed until it breaks the speed v. The length of the rope is then unchanged. Length of the rope remains the same. At what other combination of rope length and the speed will the rope break? Okay, somewhere related to length and speed. What does length give rise to? And how do you relate this length into the circular motion? When I say circular, I just give one small clue here. It's about the radius of the circle. Okay, so based on it, I'm not going to give you anything. Think about it and answer it. Now, let us move on to the next one. A small ball of weight W is attached to a string moving in a vertical circle. Very simple. Okay, and then what is the smallest kinetic energy of the ball? When you are asking about the kinetic energy, what you need to do is you need to find out the velocity. Now, Instead of saying smallest kinetic energy, now kinetic energy is proportional to velocity square. Okay, as a result of it, now you talk about the what is the least velocity. Least velocity. Let us replace this least velocity of the ball at position x. Okay, for the ball to maintain the circular motion with radius r. So what is the least velocity the ball should have? See, if it has more velocity, it will complete one full circle. It has less velocity, it will only go until here and then come back. Might be here and so on. But it should have some adequate amount of velocity to complete one full circle. What is that velocity? That's what has been the question. We have worked out this also. Think about it. Then the center of the earth is separated by the center of the moon by a distance d. Point P lies on the line joining the center of the earth and the center of the moon. Okay. A distance x from the center of the earth, the gravitational field center P is 0. Gravitational field center P is 0. What is the ratio of the mass of the moon by mass of the earth? So what you need to do is, when will the gravitational field at point P will be 0? See, point P, if you keep a particle here, what will happen? This particle will get attracted by both of them. Okay, I have already given the answer here. Now, based on this, arrive at a mathematical construct to see to it that you get the appropriate value. Okay, tomorrow we'll get the full solution. But today, try it out. Okay, you know how to calculate the gravitational field at this point. What's the formula? If you want, I'll give the formula also. DP always tells you the formula, right? Okay, formula here is G, small g, is equal to capital G, capital M divided by R square. But of course, in the exam, you will not get it. Here, I'm just giving you a clue. Okay, with this much sufficient clue, you should be able to solve the problem. Then, a satellite X of mass M orbits the Earth with a period T. What will be the orbital period of satellite Y of mass 2M orbiting the same orbit as X? So, you have one orbit. There is one satellite of mass M which is taking a time T to revolve one full rotation. Now, you have, what will be the orbital period of satellite Y? You have another satellite, but mass is twice, but the radius of the orbit is same. So once again, it also tries to move like this. Now, how much time does it take? Okay, very easy question. It's a direct question. I'm not going to give any clue over here. Just read the concepts corresponding to orbital velocity, right? You will easily get this. Then, an object of mass M at the end of a string of length R moves in a vertical circle. So there it was also the same. At a constant angular speed, what is the tension? In the previous two problems before, I had asked you about the same question, but the only thing is, the question there was, find out the least kinetic energy when the particle moves in a circle like this. At this point, what is the least kinetic energy? So the particle completes one full circle. So here, what is the question? What is the tension in the string when the object is at the bottom of the circle? When the object is at this point, what is the tension? Okay, very simple. Think about it and then answer it. Then, next, an object of mass M is moving in a horizontal circle of radius r with a constant velocity v. And what is the rate at which the work is done by the centripetal force? So how is the work done? So towards it, how do you do? An object of mass M is moving in a horizontal circle. What is the rate at which the work done is done by the centripetal force? Where does the centripetal force act? And then what is the displacement? Look at that. Do F dot S, which is F S cos 90, cos theta. Oh my God, I told you. Okay, so fine. Okay, so this I'm not going to give any mark. I already told you. If you want, you can think about it. Right. Now, let us move on to the next one. A particle moving in a circle completes 5 revolutions in 3 seconds. That is very fast here. What is the frequency? Okay, think about it, how to do it. The answer is very much evident if you know what is a unit of frequency. Okay, then. Satellite X orbits a planet with an orbital radius r. Satellite Y orbits the same planet with an orbital radius 2r. And satellite X and Y have the same mass. What is the ratio? Centripetal acceleration of X by centripetal acceleration of Y. So what do you need here? You need to know what is the formula for centripetal acceleration. Okay, which is nothing but your... Okay, I muted myself and I put it across. So you should know what is it. With using my lip movement, you can understand what it should be. So once again, if you want, I can just tell you. That's it. Okay, fine. Let me move on next. That's it. We have come to the end of the 10 problems. So hardly it have taken 10 minutes for me to explain. So happy learning. And if you have got all the solutions correctly, if you verify it by tomorrow, then good. You have really picked up your subject. And do like, share, and subscribe to my channel for more updates. Thank you. Thank you once again.